Hello everyone. Our next topic is types of elements. Our next topic is types of elements. In that, first one is linear and non-linear elements. Second one, active and passive elements. Third one is time varying or time invariant elements. Time varying and time invariant elements. And fourth one is unilateral and bilateral elements. And fifth one is lumped and distributed elements. In this first one is linear and non-linear elements. We will discuss about linear and non-linear elements. The definition is an element is said to be linear if its characteristics line is straight line and passing through the origin with constant slope for all time. Okay, so remember that it passing through the origin with a constant slope for all time. Or if element obeys the Ohm's law, then it is said to be linear element. Okay, now coming to the graphs, observe the first graph. So the line is passing through the origin and it is a constant slope. Okay, it is a constant slope for all time. All time means for positive values of current and negative values of current. So it is linear. Coming to the second graph, here also same. So the line is passing through the origin. Okay, here the line is passing through the origin, and next one is it has a constant slope. Okay, everywhere it has a constant slope, and for all time means for positive values of current as well as negative values of current. So it is linear. Coming to here, for positive values of current, it is linear. Okay, so it touches the origin but not passing through the origin, but it touches the origin up to this portion. It is linear, but negative values of current, there is no slope here, so it is non-linear. Next one, observe this graph. From this portion to this portion, line is passing through the origin. Okay, up to here it is linear. Up to here it is linear, but after this point, what will happen? Even though current is increasing, voltage is constant. Here also, even though current is increasing, voltage is constant. So it is non-linear. So coming to this graph, so here line is passing through origin, but it has positive slope, but it has negative slope. Slope is changing. Okay, so it is non-linear. Here also only in second coordinate, that means for positive values of current there is no slope, so it is non-linear. Coming to this graph, here also it is not passing through origin first of all, so it is non-linear. So it is in exponential form and negative slope is not there, so it is non-linear. Coming to this graph, so it is passing through origin up to this portion, it is linear, but after increasing the current, after this point increasing the current, voltage is constant, so it is non-linear. Coming to this graph, so this line is constant slope for all time, but what will happen if this line is not passing through the origin, so it is non-linear. Next type of element is active and passive elements. An element is said to be active if it delivers a net amount of energy to the outside world for a long period of time. Okay, if an element is said to be active if it delivers energy to outside world for a long period of time. Otherwise, it is said to be passive element. Okay, examples are all sources are active elements and RLC, that means resistor, inductor, capacitor, diode. These are the passive elements. Okay, now observe the graphs. If an element has negative slope, that means if the characteristics are lies in the second coordinate and fourth coordinate, this is active element. This is active element, that is negative slope. Okay, here it is negative slope, here it is negative slope. If the slope of the characteristic line is positive, then element is called passive element. Okay, here slope is positive slope. So that means the characteristics are lies in the first coordinate and third coordinate. Coming to here, characteristics are lies on first coordinate. So the slope is positive, it is passive element. If you observe this graph, characteristics are lies on third coordinate. Okay, this is third coordinate. So slope is positive. So it is passive element. Here characteristics are lies on second coordinate. Slope is negative. So element is active. Okay, next type of elements are time variant and time invariant elements. So the definition is an element is said to be time invariant if its characteristics does not changes with respect to time, then it is time invariant element. Otherwise it is time varying element. Coming to the graph, if you observe here, for all time it has only one characteristics. Okay, one characteristics line. But coming this is time invariant. But coming to here, for t1 time it has one characteristic line. For time t2 it has another characteristic line. For time t3 it has another characteristic line. So it is time varying element. Next type of elements are unilateral and bilateral elements. The definition is an element is said to be bilateral if it offers same impedance for different direction of current flows. Then it is bilateral element. Otherwise it is unilateral element. Okay, now consider these circuits. Here, what is the resistance value? You can take resistance is impedance in case of DC. So what is impedance value? Voltage by current. Voltage is 8, current is 4 amps. So you will get 2 ohms. From this circuit, what is the resistance value? R is equal to V by I. Here, current direction is reversed. So R equal to 8 volts divided by 4 amps, that is equal to 2 ohms. So it is bilateral element. Coming to this circuit, if we connect positive terminal of the batteries, anode of the diode, then it is forward bias. So here impedance is 0. Okay, if it is ideal diode, if impedance is 0. For suppose if positive terminal is connected to cathode of the diode, then diode is reverse bias. What happens? Here impedance is infinity, that is open circuit. So here 0, it is infinity. So this is which element? Unilateral element. This is unilateral element and this is bilateral element. Next type of elements are lumped and distributed elements. Okay, the elements which physically separable are called lumped elements. Remember this, the element which physically separable are called lumped elements. Examples are resistor, inductor, capacitor. Next one, the elements which are physically not separable are called distributed elements. The elements which are physically not separable, this type of elements are called distributed elements. Examples are transmission line elements. That means in laboratories, especially in electronic laboratory, we see that resistor, inductor, capacitor separate elements. That elements are called lumped elements. We are studying about the transmission lines. Here also we are studying about resistance, inductance, capacitance, but that elements are distributed in nature. Can't separate that elements. This is about the types of elements. In the next video, we will solve some problems on this topic. Okay, thank you for watching.